If you ever thought about making a 2D game with Unreal Engine 5, there's no better time to start than now. As it stands, Unreal Engine is lacking many features for handling sprites, and making 2D games the regular way can be quite hard. But this is where PaperZD steps in. PaperZD is an easy to use plugin that recently went from being a paid plugin to being completely free. The two most important features are the ability to handle your animation state through an animation blueprint, just like you would for 3D characters, and animation notifies, which allow you to easily play sounds or trigger functions on certain frames of an animation. I structured this tutorial so even if you never made a 2D game in Unreal Engine, you can follow along. But it's also for more experienced developers that just want to switch from Paper 2D to PaperZD. First, we'll need to get the PaperZD plugin. In the Unreal Engine Marketplace, look for PaperZD. Make sure there is no space between Paper and ZD. You can then claim the free asset if you don't already have it. Install it to the version of Unreal Engine 5 you plan on using. Create a blueprint project with a blank template. Go to Edit, Plugins, and search for PaperZD. Activate the plugin and restart the project. We are currently in an open world map, which we don't really need. Go to File and New Level. Select the basic map. I changed the color of the floor material to make the character stand out a bit more, but you don't have to do this. Go to File and Save Current Level, so we don't lose this map when we close the project. By the way, I recently started a Patreon for Cobra Code which supports the creation of videos like these. Members get rewards such as their name in the video credits, special Discord roles, and early access to my videos. If you sign up right now, you can watch this tutorial on how to get started making 2.5D games in Unreal Engine 5. Now it's time to import the assets for our character. This works the same way with PaperZD as it does with Paper 2D, so feel free to just skim through this section if you're already familiar with importing sprites and audio. I decided on the Prototype Hero demo by Sven for this tutorial because it's freely available for everybody to download, comes with sound effects, sprite dust effects, and transitional animations. So it's perfectly suited for me to show off many different functionalities of PaperZD you'll want to use in your projects. Once you downloaded the asset, unzip the package. In here we only care about the audio and sprites folder. Just drag the audio folder into your content browser or drawer. Select all of the Footstep clips and right-click. Create a single queue. This will randomly pick one of the Footstep sounds and play it. Create a new folder called Prototype Hero. On your hard drive, go into the Sprites folder and select Dust PNG and Prototype Hero No Sort PNG. Drag these into Unreal Engine to import them. In my last video, a few viewers had issues importing the images. If you're having issues, you can try to use the import button here instead of dragging and dropping the assets. If that also doesn't work for you, you might want to open up the asset in an image editing software of your choice and export a fresh PNG to make sure nothing is corrupted. Now you should be able to see both of these textures in your content browser. Right-click them and apply Paper 2D settings. Right-click the Prototype Hero texture and click on Extract Sprites. For Extract mode, select Grid. We need to manually set the width and height. You can see that there are 8 sprites in a row, so we can simply divide the value by 8 for the width. A column has 3 sprites, so we can just divide the height by 3. When you open a sprite, you can see that the pivot point is in a weird position. For this character, we want to set it to bottom center. Doing this for every single sprite one by one would take a lot of time, so select all of the sprites and right-click. Go to Asset Actions and bulk edit via Property Matrix. Make sure all the rows are selected and set the pivot mode to bottom center. Then save all to apply this. Let's first create the idle animation. Select frames 0 to 5 and create a flipbook from them. When you open this up, you can see that the animation is playing a bit too fast. The asset creator provided some information on recommended frame rates. The idle animation should play at 6 frames per second, which we can set here. The run animation consists of frame 8 to 15, so create another flipbook. Set the frames per second to 12 for this. For now, we only need these two flipbooks. In the content folder, create a new folder called Blueprints. And within that, another one called Hero. When you right-click in the content drawer, you can see that there's a new section for PaperZD, which has 3 different asset types. The first thing we'll create is the animation source. This is basically just a collection of all the animations which we want our animation blueprint to be able to use. When you open this up, everything is pretty much blank. You can click on Add New to add a new animation sequence. For the animation data, we want to select the idle animation. We can then right-click on our sequence to rename it, or just hit F2 when it's highlighted. Let's call it idle. When we open the content drawer, we can see that a folder called Anim Sequences has automatically been created. When going into the project settings and checking the settings for PaperZD, you can actually adjust this to your liking. When we go into the Anim Sequence folder and right-click, we can also create an animation sequence here. We then need to pick the parent animation source. Call it Run. You can see that this now shows up in our animation source editor window. Both of these methods of creating anim sequences do the exact same thing, so you can just go with the method you prefer. Double-click on the Run sequence. For animation data, select the Run Flipbook. The next thing we need is an animation blueprint. We again need to select which animation source this is connected to. In here you now have the event graph and the animation graph, just like you do when working with regular animation blueprints for skeletal meshes. Let's have a look at the output animation in the animation graph. This determines which animation is being played on the flipbook, but right now nothing is connected. As the first step, we can simply connect play idle here. Compile and save. Then create a new blueprint class. Expand the All Classes dropdown. Select PaperZD Character. This blueprint will allow us to easily set up a sprite character which uses the animation blueprint. The important factor here is the animation component, which is provided by PaperZD. The only two settings we care about is the Anim instance class and the render component. The render component is already set to our sprite component, so we don't need to touch this. The Anim instance class needs to be set to our animation blueprint we created before. We can now go into the map and drag out this blueprint to confirm that it works. Set play mode to simulate and pan the camera to look at the sprite. This confirms that we set up the connection to the animation blueprint correctly and PaperZD is controlling our flipbook. However, the sprite is really small, so let's go back into the hero blueprint. On the sprite, set the idle flipbook. Set the scale of the sprite to 4 on all 3 axes. The Z location should be -97. We'll need a camera to see our character when we control it. Select the capsule and then add a spring arm component. Then attach a camera to it. On the spring arm, set the target arm length to 500. Then rotate the spring arm around so we look at our character from the side. Now we want to set this as our default character, so create a new blueprint of type game mode. Go into project settings and maps and modes. Select GM_base as the mode and also set the default pawn to BP_hero. While we're at it, also set our map_basic as the default. Delete the hero character in our map. When pressing play in viewport, you can see that our character now spawns and we're possessing it. We now want to conditionally switch from the idle to the run animation, however our character can't even move yet. Go into project settings. Input and create a new axis mapping. Call it forward. Press on D and set the value to 1.0. Add another row. Press on A and set the value to -1.0. While we're at it, also add an action mapping for the jump and set it to the spacebar. And also an action mapping for dash, which should be set to left shift. Go into the blueprint of our hero character and open the event graph. Add the forward event. Then call add movement input and connect the axis value to the scale value. Set the X on the world direction to 1.0. When we play now, you can see that the character can walk, but the directions are messed up. We can fix this easily by dropping a player start into the map. If it says bad size, just drag it upward a little bit. Our character can now move around, but we need to switch the animation to running. Let's go back into the animation blueprint. A very simple way to switch between animations is to use select animation by bool. We can then get owning actor to get a reference to our character. Then get velocity. And split the struct bin since we only care about the X value. Then we check for not equal to 0.0. This means when our character is not standing still, true will be used, so connect run to true. And then idle to false. Now you can see that our character properly switches between the idle and run animation using PaperZD's animation blueprint. A very useful functionality in the animation blueprint is that we can make parameters of the animation sequence dynamic. We can, for example, tick this box on the run animation to expose the play rate. To make proper use of this, go into the hero blueprint and create a new variable called run play rate. Make it a float. Compile and set the default value to 1.0. Add the dash event we previously created in the input menu. When the dash button is pressed, set the play rate to 1.5. And when it's released, set it back to 1.0. We can also update the max walk speed on the character movement to match that. When the dash is activated, set it to 900. When the button is released, set it back to 600. Go back into the animation graph. We now want to get this run play rate value from our hero character. However, get owning actor does not know about this value. A quick way to get it is to just cast the actor to BP_hero and get the run play rate from there. When you start the game, this does work perfectly fine, but casting on each frame in the animation blueprint is bad for performance. So let's delete these nodes and do it another way. Click on Event on Init. This event is only triggered a single time when the animation blueprint is initialized. Here we can get owning actor and cast it to BP_hero. Then promote this to a variable called hero. Since we're only casting a single time now, this is a lot more performant. In the Anim graph, we can then just drag out our hero and use the run play rate. We can then also use the hero variable up here for more clarity. Let's add some footstep sounds. If you were to do this without PaperZD, it's actually quite cumbersome. You will have to check each tick which animation is currently playing and on which frame we currently are to decide if we need to play the sound or not. However, with PaperZD we can simply go back into our animation source and add an Anim notify. You can grab the playhead to find the frames on which our foot touches the ground. In this case, it's frame 2 and frame 6. Right-click to add a notify. We can use play sound, which is already there by default. For the sound, we can select our footsteps _Q, which we prepared at the beginning of the tutorial. You can then right-click this label and type in the frame number to put it exactly in the position where frame 2 starts. You can then simply copy and paste this notify and set it to frame 6. Click play here to see if the sound is being played correctly. When playing in editor, we can also see that everything is working fine. Let's add a jump to our character. First, go into the character blueprint, and at the jump event we set in the inputs before. Then simply call jump on pressed, and stop jumping on released. Now the character can already jump, however we need to switch to the jump animation. Let's first create the flipbooks. Use frame 19 for jump. Frames 20, 21 and 22 for jump transition. Set the frames per second to 12. Use frame 23 for fall. And frames 16, 17 and 18 for land. Set the frames per second to 12. Now create a new animation sequence for each of these flipbooks and set the animation data correctly. Back in our animation blueprint, we want to add the animations for jumping. We could go here and daisy chain even more select by bool nodes together, however this would get messy real quickly. Let's delete all of this. And create a new state machine instead. Call it locomotion. This will help us keep things clean and handle more complex states. Let's first create an animation state. And call it idle. Open it up. In here we have an output node. We simply have to play idle and connect it. Then create another state and call it run. In here we play the run animation and expose the play rate. Now we can again get a run play rate from the hero character and pass it through. We need to define conditions for switching from one animation to another. Just like before, we check the velocity on X of our hero and allow a transition to run if it's not 0. We can then copy-paste these nodes and create a transition back to idle. Here we want to check for is equal. Now our idle and run works the same as before, but it's a lot cleaner and sets us up for implementing the jump. I'll first show you how you probably don't want to implement this, so don't follow along with this part and just listen. You might think that you just want to add the jump state here and connect the transition. And this does totally work, but this gets messy real quickly again, since you need to be able to go to jump from pretty much any state and also transition back. We can make this more compact by using jump nodes, which are a new feature of PaperZD. Create a jump node and call it airborne. Connect the jump state here. Then also the fall state. Then connect this back to run. Go into the jump state and play jump. Since this is a single frame only, we don't need to loop it. For the fall, we play fall and again don't loop it. Let's decide how to transition from jumping to falling. We again get the velocity of the character and break the struct. We can check for the apex of the jump by seeing if the z value is smaller than 0. For the transition to run, we just check for is walking. Now we want to trigger the jump to this node in the character blueprint. We can go into the function overrides and add the onJumped event. And also the onWalking off ledge event. Get the animation component and its Anim instance. Here we can call jump to node. Input airborne as the jump name. You can see that we properly transition into the jump state when jumping, or also when falling off a ledge. Our transition from jump to fall is a bit stiff though, but we can make this smoother by using a transitional animation. In the animation graph, you can click on the transition between jump and fall. Check Use Transitional Animation. Then click on Open Animation Graph. Here we can then just play the jump transition animation we prepared before. Now when we reach the jump apex, the transition between jumping and falling looks a lot better. Let's add an animation for when we land. We can again create a jump node and call it landed. Then create a state and call it land. In here we play the land animation we prepared before. Make sure that it's not looping. Then add a transition back to run. We want to transition back once the land animation finished playing, so let's get time remaining land. If this is smaller or equal to 0, we can transition back to run. We now need to trigger the jump to land it in the character blueprint again. Overwrite the onLanded event and copy-paste these nodes for jumping. Change the jump name to landed. You can see that we now play a landed animation, however our character can still slide over the floor while this animation is playing. We want to give our landed animation some weight and have the character stop for a bit. In the character blueprint after the onLanded event, we can then call stop movement immediately on the character movement component. Then create a variable called isMovementLocked and make it a boolean. Here we can then set this to true. On our forward event, we can then check for this boolean and only execute addMovementInput if the movement is not locked. Now our character will stop when going into the land animation. However, we now get locked into the state and can't start walking again. Now you might think that you want to add an Anim notify at the end of this animation to clear the locked state. But let's just try this out so you can see why this isn't a great solution. An Anim notify will allow us to trigger a function at a certain point during an animation. When we create a notify, a new function will automatically be created for us in the animation blueprint. We can then use this to set the isMovementLocked boolean back to false. The first thing you'll notice is that if we put the notify all the way to the right, it actually won't trigger since frame 3 doesn't actually exist. If we put it somewhere between frame 2 and 3, it will trigger, however a bit early. But the worst thing that could happen is actually that we get launched or stunned before reaching the Anim Notify and another animation starts playing. In that case, the function will never get triggered and will be soft locked, which is a really bad thing. Let's get rid of this Anim Notify and do it a different way. In the event graph of the animation blueprint, we have access to an event from PaperZD called onAnimSequence playback complete. This will be called every time a non-looping animation finished playing, which we can see by setting a print string. Now we can just set isMovementLock to false here. And now we get exactly the effect we want. Our character will shortly stop when landing and can then start walking again. To show you more advanced Anim Notifies though and give you an example of what you can do with them, there is one more thing I want to implement. I want to create a shockwave when our character lands that spawns a dust effect and can knock other characters away. In the beginning we imported a sprite sheet with dust. Right click it and extract the sprites. Set mode to grid. The grid width and height will both need to be divided by 4. While all of the sprites are selected, right-click and edit via property matrix. We want to set this pivot to bottom center again. We only care about frames 8 to 11 and create a flipbook from them. Set the frames per second to 12. For this effect, we now want to create a blueprint class of type actor. I'll call it BP_land_dust. Here we want to add a paper flipbook and select the source flipbook of our land dust. Set the scale to 4 just like we did for the character. On begin play we want to get this flipbook and set looping to false. In the flipbook we can then scroll down to events and add on finished playing, and then just call destroy actor. This means the animation will play once and then the actor will be destroyed automatically. On the hero blueprint, create a function for spawning the dust actor. Spawn actor from class and select the BP_land_dust class. Split the transform pin. Get the world transform of the sprite and also split the pin. Then connect the location and rotation. We don't care about the scale. To call this function and also implement the shockwave, we now create an Anim Notify asset, which allows us to pass through values from the editor. Create a new blueprint class and go to all classes. Search for PaperZD and select PaperZD Anim Notify. We can then add this notify to our animations. When you open up the Notify asset, you can see that there are two functions to override. GetDisplayName will simply override which name the Notify displays on the animation sequence. The onReceiveNotify event will trigger when the Notify starts. From the Anim instance, we can get the paper character and cast it to BP_hero. Then we can call spawnDust. Ideally, you'd want to use an interface here instead of casting for performance reasons, but that's a topic for a different video. So far, this is something we could have still done with a regular Notify, but now we'll add the knockback effect. First, we want to visualize the area of our effect. On receive notify, we can use a little trick to check if we're currently in the game or in the animation sequence editor. When the owning instance is not valid, we know that we're in the editor. If we're in the editor, we want to draw a debug sphere. First, set the duration and line thickness to 0.1. We want the position and radius to be easily editable, so let's create a variable for each of these. Then connect them to draw debug sphere. Don't forget to compile and save. These variables then become available in our animation sequence. Let's set the radius to 30. You can see that we now draw the debug sphere in the editor. We could also change the position here, however 0, 0, 0 is correct in this case. Let's implement the actual functionality. Call sphere overlap actors. For object types, make an array and select pawn and physics body. For the actor class filter, select character. For actors to ignore, make an array and pass our BP_hero. We'll set sphere pos and radius later. On the out actors, call a for each loop. Cast the array element to character. Then call launch character. Create a vector up node and multiply it. Here we can just set a float of 1000 for now, but you can also turn this into a variable. Now back on the sphere overlap, we can connect the radius, however the position is a bit more complicated. We need the position in world space, but the one we set in the sequence is in relation to our sprite. We need to get the world location of the sprite and add the position to it to get the world space value. Add another character to the scene on the same line as our player spawn. Now when we jump near the character, it should be launched, however it doesn't quite work yet. To figure out what's wrong, let's also draw a debug sphere in the game and connect the same values. In this case, set duration and line thickness to 1.0. Now you can see that the sphere is actually a lot smaller than we expected. The issue here is that in the blueprint we set the scale of the character to 4, but the animation source doesn't know about this and only shows the sprite at the regular scale. In case you set up the pixel per unit settings so you don't have to scale your sprite, this actually is a thing you don't have to worry about. From the sprite we can get the relative scale 3D and split the pin to only use the X value. We can now multiply the position by this to scale it. Then also multiply the radius by this. Connect the new results to the draw debug sphere. Now you can see that our sphere matches the size we had in the animation sequence and we are correctly launching the other character. If you want to properly play the fall animation here, you'd need to go into your BP_hero and overwrite the onLaunched event to let the animation jump to airborne, just like we did before for falling. Now we can delete the debug sphere. I hope you understand how powerful of a tool this is, since it gives you complete freedom in how you want to use it. and also allows you to differentiate between being in the game or in the editor. One thing we still need to add to complete our character is the ability to turn around. This is a pretty loaded topic by itself, so I'll just provide notes in the Unreal Engine dev community you can copy and paste into the event graph of the BP_hero. When we switch directions now, the camera boom rotates with us though. You will want to set your spring arm rotation to world to prevent this behavior and use absolute rotation. At this point you'll have to decide if you want to make your game full-on 2D, in which case you can check out this video, which also has a section on how to build levels from tile maps. Or you can also create an HD 2D game which only uses sprites for the characters but has 3-dimensional backgrounds, which this video will help you set up properly. Also, I want to say thank you to my first Patreon supporters.